This is the weekly update for Mr. Fix's science class for the week of March 19th. Alright, so again, every day we do magnetic fields reviews. Let's take a look at that, a little bit about that. Alright, so again, on the upper left-hand corner of these slides, it tells you what lesson the review is from. And so we go at the beginning of the period most of the time each day. It's usually vocabulary words, some key concepts we fill in, and some visuals. So we do that every day. That gets them kind of a mindset of, hey, this is what we learned yesterday, and so it's going to build on today's lesson. All right, we did 2.2 lesson for Monday and Tuesday, so let's take a look at that. All right, so it's all about magnetic fields, exploring potential kinetic energy. Always have a warm-up, and then they share their ideas about kinetic energy. Basically, kinetic energy, the faster something goes, the more kinetic energy it has, the more motion it has, basically. And we're looking at how can magnets cause objects to have kinetic energy. So they read about, last lesson, 4 different articles about athletes and kinetic energy and how they actually get the kinetic energy. So basically, at some point they store the energy, this potential energy, in whatever devices they're using, or legs or anything like that. Then that gets converted into kinetic energy by force. And this is the diagram that kind of shows that. So there's at least 2 parts of the system. Again, there's stored potential energy, and a force converts that potential energy, some of that potential energy, into kinetic energy. So we wrote that vocabulary word down, potential energy, on page 21 of the notebook, and convert to change from one type to another. And then we did some exploration with hands-on materials, a couple of systems in which potential energy was converted to kinetic energy. So maybe using a spring, a pom-pom, a rubber ball, a magnet. And so they had to do that and write down their ideas in the activity 3 page. So I identify the parts of the system. How did you add energy in each system? How was energy converted to the system? All right. So basically, we learned how potential energy is stored. In an invisible magnetic field, the potential energy is stored. Again, a force is needed to insert energy into the system as potential energy, and then at some point, the force converted the potential energy to kinetic energy. So key concept, magnetic force can convert potential energy stored in magnetic field to kinetic energy. And they left with a little bit of a homework assignment. So that was over Monday and Tuesday. Wednesday, we did lesson 2.3, all about magnetic force and potential energy. So I did a little warm-up with this little handout modeling tool. Basically, again, how is potential energy converted into kinetic energy in a magnetic system? Basically, in the magnetic field, potential energy is stored between 2 magnets. Then they had to simulate these energy changes. They wrote down the word transfer to move from one object to another, or one place to another. Again, we're looking at how does a system of magnets store potential energy in a magnetic field. We had 2 claims. Claim A, potential energy increases when the magnet's moved with the magnetic force, whether it's attraction or repulsion. And claim B, potential energy increases when a magnet's moved against the magnetic force, again, whether it's attraction or repelling. So they use features in the sim to do this, including looking at the potential energy readout in the sim. That was a key one. All right, so basically in the sim, whether it was force of attraction or repelling, in this case I'm going to show repelling. And we look at the potential energy between the 2 magnets, 2,722. If I move it against the force of attraction, because the force of attraction in this case is away from each other, I'm going against that force, going toward each other, I see that the potential energy increases in the system. And then if I move it farther away, I see that the potential energy has decreased in the system. That's going with the magnetic force. All right, so that's what they did for that activity. Then they had to write and share force and energy. Yeah, one of that kinetic energy comes from potential energy. However, we don't know where potential energy comes from. So in the sim, you observe that potential energy came from moving the magnet against the magnetic force. And so they had to write about 3 different evidence cards. So let's take a look at that. All right, so for this one, we have pom-pom and spring. And basically, the spring's force is always outwards. And so if you compress it inwards, you're going against the force of the spring, and you're putting energy into the system and storing it as potential energy. And then when you let it go, the force of the spring converts that stored potential energy into kinetic energy of the pom-pom. And so that was one example. We had other systems to take a look at. And this is the process in which they did it. All right, so again, to put energy into the system, you had to go against the force. In this case, we have like poles. It's a force of repelling. So if you place the magnet closer together, you're going against that magnetic force, putting energy in the system as shown in this diagram of these graphs. And then you let the magnetic force do its thing, and it repels and it pushes the magnets, and it converts some of that potential energy into kinetic energy the magnets move. So key concept number 5 they wrote down at page 20 of their notebook. The energy used to move a magnet against a magnetic force is stored as potential energy in the magnetic field. And that was basically the end of that lesson. And then we did lesson 2.4. So lesson 2.4, basically, they're taking a closer look at the spacecraft launches and simulating them. All right, so this is a kind of review of the last lesson of how potential energy gets into the system and how it gets converted to kinetic energy once it's in the system. So that was a little warm-up. And we talked about how defining system when you have to identify the parts. So for example, we have a ball launcher and a ball, so that's one part of the system. And to get energy into that ball launcher, you have to transfer energy into it, going against the force of the spring. So by compressing the spring, you're going against the force of the spring. You're putting energy into the system as potential energy. It's stored energy, and then the force of the spring, once you let it go, converts that stored potential energy into kinetic energy and makes the ball move. Now, to get that going, we had to turn the crank to transfer kinetic energy to the flywheel. Flywheel moves its belt to compress the spring. So that was happening in that system there. So that was an example. Again, when you have one, if you just have one part of the system, it's not a system. It's just one component. So there's no stored energy in there. You got to get 2 components in the system to get potential energy in. And again, you're going against the force that's there. In this case, the force of repulsion by placing the magnets close together. And then you let go, the magnetic field applies a force on both magnets to convert some of that potential energy, kinetic energy, and makes them move. So basically, they got some information about spacecraft and why did the Wednesday's launch go so much faster? The spacecraft launch had a much higher speed than on Tuesday's launch. And so they were focusing on that claim number 2. The launcher system had more energy in it, and that's why the spacecraft launch had a higher speed. So they used the sim. They placed 2 magnets in the sim. Let's go take a look at that real quick. Let me go to it. All right, so they had to use 2 weak magnets. They had to lock one of them down, and that's going to simulate the launcher magnet. And then the other weak magnet that's not locked down represents the spacecraft. So they had to space them 4 dots apart, and they had to record the potential energy into their data table right here. Monday's launch 4 grid points between the magnets. Then they had to run it. And then in analyze mode, they had to find the amount of potential energy after launch and the amount of kinetic energy after launch. And so they recorded that information here and here. And these 2 numbers together added up the potential energy before launch. And so for Tuesday, they had to make the magnets 3 grid points apart, and Wednesday 2 grid points apart. Well, it looked like something. It was basically you had greater kinetic energy after launch and greater potential energy before launch when the magnets were closer, because you're putting more energy into the system because you're going against the force of repelling. So that's basically what it was. And so that supports claim 2. Much more energy was in the launcher system on Wednesday and Tuesday because the magnets were closer together. All right, so that was supported. And then they were given this modeling tool to demonstrate what for Tuesday's launch and Wednesday's launch, how did more potential energy get into the system on Wednesday's launch compared to Tuesday's launch, and how did that result? So we did that, filled that in, and they kept that paper. And then we copied down the key concept number 6, creating a model of magnetic system and defining its parts help scientists test and explain the relationship between force and energy. So that was Thursday. Then on Friday, we did some magnetic fields vocabulary practice using the Quizlet vocabulary set. They could do multiple ways of learning you could have multiple choice, so that's learn mode. They could do write, they could do spell, they could do test, they could do matching. They could do lots of different methods to do that, to learn the material. And then we had a Kahoot review game where there was prizes. It was a group review game where they had to work together to find the answer. And we're going to have a kind of a chapter 2 little of kind of mini quiz on Monday, and that's why we did the practice today. And again, they had to add to page 20 and 21 of the reference notebook this week, so we have a link to that, which takes you here. So they got through key concepts number 6, and then they got through the vocabulary words up to transfer. So that's what we did this week. Hope you have a good weekend. Bye-bye.